Thank you. Well, welcome to my session. My name is Pascal Naber. I'm from the Netherlands, and I work for Xspirit. I'm an Azure Cloud consultant. I'm also nominated by Microsoft as Azure MVP. And well, this session is about Kubernetes, of course. I work for Xspirit, and at Xspirit, we do epic shit. That's also why I wear this t-shirt, and it's the motto of our company. I have some swag to give away. If you like a laptop sticker, I have several here. Not for all of you, I'm sorry. So if you like it, grab one after the session. But you can also get a t-shirt if you like. I have one t-shirt in each size, and I have hidden some Do Epic Shit logos in my slide deck. So if you tweet a picture of me and the slide, and tag me, of course, and the conference, and then you can win a t-shirt. So first come, first serve. Just find me after the session, and you can get a t-shirt. So let's begin. 8 lessons learned, and actually, I lied a bit. It sounds so nice, 8 lessons learned with K8S. So that was actually the reason of the title. And this session is about the lessons that I learned at a big enterprise in applying Kubernetes. And I learned much more than 8 lessons. So I'm also going to tell you much more than 8 lessons. So the good news is you'll learn more. I have a lot to tell. And yeah, first, something about this, the similarity between Netscape and Kubernetes. This is the second time that I do this session, and I noticed in the first session that people didn't know what Netscape is. So who don't know what Netscape is? Oh, everybody does. Really amazing. The previous conference, a lot of hands showed up. But that's good news, because Netscape was actually the inventor of the icon of Kubernetes. So I found that pretty nice to see. But so the session. This is not an in the beginning session. So I'm not going to explain what Kubernetes is, what Docker is, how you do it, what the concepts in Kubernetes are. This is about the Azure Cloud. Hopefully you are familiar with it. So not an in the beginning session. Where am I going to talk about? Well, the session is divided in 3 sections. The first section is about the provisioning of Kubernetes on Azure. After that, we need to configure the cluster because we want to run our applications on it, and that's the next part. And during these 3 sections, I will talk about a lot of concepts. Infrastructure as code, monitoring, updates, and much more. So let's begin. And of course, I told you before, I'm in an enterprise scenario, so we need an AKS cluster. So we open the Azure portal, of course, and we create one. Hell no, that's not how we do it, of course. We want to have a solution which we can provide, which we can provision every time on the exact same way, and we need a reliable solution for this. So we need infrastructure as code. So for example, like this. You can provision an AKS cluster on Azure using Terraform, using ARM templates, and I like the CLI. I don't like it only because it's the CLI and it is idempotent on itself. It's also because the AKS team treats the CLI as a first citizen. So new functionality can always be found in the CLI. So with these 2 single lines of code, you will get a Kubernetes cluster. But you won't be in control. And I will tell you what I mean with that. So actually, I'm not going to do it like this as well. But how are we going to do it then? Well, this is a really big project. I'm talking about an enterprise. And this enterprise supports 80 branch offices all over the world. And we need our application to be available for all these branch offices. So we have different time zones and many teams that are using it. So before we know what we need, we have some requirements. So for this section, for the provisioning section, we have multiple teams that are using the AKS cluster. Each team, of course, needs multiple environments to work on. So development, staging, production. This enterprise has a security department, and they only allow us to provide APIs to the end users with a firewall. So we need a level 7 firewall in front of our APIs and web applications. Okay, that's a big requirement that has a lot of consequences. And because of all the branch offices that I talked about, we need high availability. I'll talk about that as well. So first, how do we support multiple teams? Well, you can design your clusters the physical way, so then you will get a cluster per environment per team. You will end up with a lot of clusters. On the other hand, you have the logical way. Then you are going to reuse clusters, and multiple teams are making use of one cluster. You will end up with less clusters, so you don't have to maintain the clusters. Well, you have to maintain them, but not as many. And you make better use of resources. Microsoft is advising the latter. My lesson learned is something in between would be better. We think time to market is really important. Teams should do something what they want and don't have to be dependent on other teams. So our experience is that give teams an AKS cluster in development for their own. So they can do whatever they want. They can test things out and don't have to ask other teams before they can do that. On the other environments, well, it would be nice if they have their own cluster, but it's okay to reuse clusters because we are automating the provisioning and it really doesn't matter if it is a reusable cluster or not. So that's a thing. The next part, the firewall. In Azure, you have the application gateway and firewall. It's a resource. It's a very powerful resource. Actually, it combines two services. It's a load balancer, and optionally, you can enable the firewall. If you enable the firewall, then you're secured for OWASP rule sets. So SQL injection, that kind of things. There are two versions of the web application gateway and firewall. Version 1 is based on IIS, and version 2 is based on Nginx. The version 2 is released this year, and we are very happy with it because with the previous version, the version 1, it took at least an hour to provision it. It's really slow. And now, I think 15 minutes for the firewall alone. I try to tell you exactly what we have used in this enterprise scenario, but sometimes Microsoft or other teams and projects are working on related stuff, and this is such a sample. We keep an eye on this, for example. This is a component, an Ingress controller, which can communicate with the application gateway. So it is maintained by Microsoft, it's open source. In the meantime, it is general available. So you could use it, it is interesting. We are not using it at the moment. So nice, we have the firewall. How are we going to provision this? Well, if you use a firewall, you also need a public IP address and a VNet with subnets. I'm going to show you some scripts. At the end of the session, there is a link to my GitHub account, and you can find all the scripts there. You can execute it because it works right away. So you have the whole setup that I show you. You can have it after my session yourself. So I'm not going into detail into the scripts that I show you. It's just to give you a nice overview. So first, we are going to provision the VNet with subnets and the IP address. And finally, the application gateway and firewall. The firewall was optional, so it is really a second command line that we execute. This application gateway is really complex to configure. There are a lot of components inside this resource. So you have to configure a rule, but it consists of a listener, HTTP setting, and backend pool. The listener is connected to the public IP address, and the backend pool is connected to the private IP address of the AKS cluster. And in between, you have to configure a lot. The gateway supports SSL offloading, then you only configure a certificate on the listener. If you want to have SSL end-to-end, then you also have to configure a backend certificate. A lot of work. This is how you configure it. And then we have a nice firewall, and the security department is very happy, we are compliant. Next step, high availability. And maybe you think, why do you need to do something about high availability? My Docker containers are high available by default in Kubernetes. When a pod goes down, Kubernetes makes sure that the pod comes up again. And when a worker node goes down, the pods are catched by the other worker nodes. So what is the problem? Well, what if a region goes down in Azure? That's a bigger problem, and it happens sometimes. The solution is very simple. You can just provision your resources twice, but to a different region. But now I end up with two endpoints in this case. There is a service in Azure called Traffic Manager. And now all traffic goes to the Traffic Manager. And this Traffic Manager is really powerful. It helps us several ways, not only for the high availability. So if one of the AKS clusters is down, the Traffic Manager will notice this and will send all traffic to the cluster that still works. But it also knows how long it takes for a user to access a cluster. So the user is routed to the nearest cluster. So the user experience is better as well. A very powerful and simple service and fast to configure. It is DNS based, by the way, so you don't have an IP address, you have a DNS name. Talking about high availability, this is in preview. We can't use, and you should not use this in your production environment. It's not allowed by Microsoft. But availability zone support is coming for AKS. You can already try it out. By default, if you provision a cluster now, then your worker nodes are provisioned in an availability set. And that means that's just a rack. And there are multiple racks, so each worker node will be deployed in a separate rack. So the power consumption, for example, is already replicated. But other hardware services like cooling, you are sharing that. But with availability sets, you really have a separate environment. One region actually consists of multiple data centers, and then your worker nodes are within the same region in multiple data centers. So it is much more reliable, and we can't wait to use this because then we are more high available within one region already. So we end up with a traffic manager and a DNS name because we don't have an IP address. And what we have also learned, this is the provisioning of it, but we have also learned that we can use a DNS zone. So we actually want to use a nice domain name, of course. And I was not aware that this was possible in Azure, but you can just configure DNS as well. So now we have the whole setup of a project configured in Azure. Really nice. We are not ready to provision AKS yet. We are not there still. We need more resources before we can do that. I've now provisioned log analytics for monitoring. And log analytics is not supported by the CLI, so I have to use an ARM template, which is executed by the CLI. And then we need some service principles and a key vault. So first, a service principle for the AKS cluster itself, and that is being used by Kubernetes. For example, if you provision a load balancer service, then it will create an IP address in Azure. That IP address is created by a service principal, this service principal. All secrets, also when I create a service principal, and again, you can find it in the scripts, there is not a single password that you can find in my script. That's a bad practice, of course. It's not allowed to have passwords in your Git repos. So all secrets will be stored in a key vault. It's also generated by the script. And you should actually use secrets always. You should always use the key vault for secrets. We need another service principal, and we are using Azure DevOps to deploy our resources. And it needs access to Azure to provision everything. This is the service principal that has access to Azure from Azure DevOps. the service principal should have access to the key vault, otherwise it can't read the secrets. That's this part. And then finally we are there. We can provision our AKS cluster. And as you can see, I give a lot of parameters. The service principal that we just created and the credentials are fetched from the key vault right away. We created the VNet with the subnet, and we passed the subnet details here. The log analytics for monitoring. So we enable one of the add-ons, monitoring, and we pass the details. We pass more details here. For example, the virtual machine size. You can only do that once. You can't change the virtual machine size after provisioning. So the only way to change the virtual machine size is provisioning a new cluster. Again, there is a preview which you can use right now called node pools. And as soon as that is GA, general available, then you are able to change the virtual machine size by changing node pools. But till now, you have to provision a new AKS cluster. So if you compare this with a single line, in both situations, you will have an AKS cluster running. But now we are full in control. We decide where resources are stored, like log analytics, and which resource groups, which service principals being used, and you use advanced networking with the VNet, which is needed for the gateway. Sometimes it's needed to have a new AKS cluster, for example, which I just said, for the virtual machine size. So this setup supports that you can provision multiple AKS cluster, because you still want the high availability. Besides that, I've also provisioned a container registry. We want a private container registry for all our Docker containers. And we are using Azure Container Registry for this. And you need to set up a service principal to access this as well, because it is a best practice to disable the admin account on it. If you use it, try to get rid of it. So these are all the resources that we are using in our setup. It's a lot, but actually it's only needed for production, of course. Only in production we need the high availability of the multiple regions. For development, this is enough. And actually the traffic manager was not needed here, but we like to have as much as possible the same environment in development as in production. So that's the reason why the traffic manager is still there. How are we doing this? Well, we are using Azure DevOps, but I like to have a setup which I can run from any machine, from my local machine, and in Azure DevOps in this case. So I end up with, in this case, 7 scripts, and you saw the scripts because they were shown in the slides. And I have one main script provisioning development in this case, so this contains all variables for the development environment. And at the bottom, you can see that the provisioning script is called. This is the way we provision, and it works great, actually. So we have 3 scripts for the write, 1 for staging, and 1 for production as well. So this was the first section, and we learned a lot already. We learned that teams should be in control, so give them their own AKS cluster. Time to market is much more important than a bit more resource cost. We automate everything. I will tell it multiple times during this session. And that sounds nice and easy, but it costs a lot of time. It's really time consuming, but the result is really nice. Then we are really fast, and time to market is even faster. The security department wants to have this level 7 firewall, and we made it in our architecture. It made it much more complex, so it is a really big requirement. So if you need it, there are big consequences. The traffic manager is really powerful and gives a lot of advantages. The key vault for all secrets. And as you can see, provisioning a Kubernetes cluster is much more than AKS alone. There are many resources involved. So now we have an AKS cluster running. Great, but we want to run our applications on it, of course, our Docker containers. But we are not yet there. We have to do something about configuration on the AKS cluster. For example, the dashboard. It is not working by default, and I will show you what you have to do. We need Ingress, because we support multiple applications within our cluster. And of course, we have a cluster now, but we don't want to have a lot of maintenance on the cluster, as less as possible. So what are we doing about that? If you try to start the cluster with kube control proxy, then you get the following screen. You get a lot of errors. And that is because the dashboard doesn't have any access to your Kubernetes cluster. You can execute this line, and now we give the dashboard cluster admin rights. So that means it can do anything at once. It has all access rights on your cluster. Works great. And for development, it's fine. But in production, we have other requirements, because also in Azure itself, nobody has access. Well, we do have access. We can change anything. We only have read-only access to our production environment. That makes sure that we have to automate everything. So actually, we also want to have a read-only dashboard in production. And that is possible. We can just use the standard role view, and then the dashboard is still working, but you can only see what is happening there. So this works great for us. Ingress is one of the most advanced concepts in Kubernetes. Ingress is being used as an internal load balancer to route traffic to one or multiple applications. Ingress is there by default. You configure it actually per service, as you can see in this drawing. But you need an Ingress controller. And the ecosystem of Kubernetes, or around Kubernetes, is enormous. You can choose which Ingress controller you like. For example, traffic, maybe Istio. I'm using Nginx in this case for this customer. It's good enough for us. There are multiple add-ons that you can configure on your AKS cluster. Next to monitoring, which we already enabled, you can also configure HTTP application routing. We tried this, and actually Microsoft tells you that you should not use it in production. So that makes it for us unusable, because if we can't use it in production, then we don't want to use it in development, because we want to have the same environments, remember? So how are we doing this? Well, we are using Helm. I will explain what Helm is in the next slide. We are using this tool, and we are applying an upgrade. That's also something we learned. Never do a Helm install, because you won't be able to upgrade your applications anymore. So always upgrade, and then you pass the install command with it. At the end, you see the YAML file, and that contains variables. In this case, the static IP address, the IP address of the AKS cluster. So Helm, what is Helm? Helm is the package manager of Kubernetes. You can compare it with NuGet or NPM, for example. A package is called a chart in Helm. And there are a lot of charts out of the box created by the community by default. This is only a small list here at the right, but there are much more. So very handy, because now we can use all these tools with single lines of code, and it makes it easy. Let's talk about the maintenance of our cluster. It's called Managed Kubernetes, but it is not fully managed. A part is managed, actually. A Kubernetes cluster consists of master nodes and worker nodes. The master nodes are fully managed by Microsoft. You don't see them, you don't have to maintain them, you don't even have to pay for them in Azure. They are free. And there are worker nodes. The worker nodes are running your pods, your Docker containers. These worker nodes are just IaaS, infrastructure as a service, so they are just virtual machines. But I call it actually, it is managed IaaS, because in IaaS, you are responsible to apply security updates and other updates to the operating system. I call it, it's a term that I use, I call it managed IaaS, because in this case, Microsoft is applying the security updates and other updates. That's nice, and Microsoft tells you that you only have one responsibility, and that is you have to reboot your virtual machines. Luckily, the ecosystem is very rich around Kubernetes, and there is this project, KURT. And KURT makes sure that when it's needed, it reboots your virtual machine, one by one, luckily. So again, Helm, and you can also configure KURT to have Slack integration. So you can see that at the right. We can exactly see in our Slack channel when KURT reboots our machines. And it happens so once in the 5 days. So we have still IaaS, virtual machines, and actually the next step would be to have a real platform as a service. I don't want to maintain virtual machines, I just want to use a service. And I would want to tell you more about this feature, but the next speaker will talk about this topic more. So just in short, Microsoft offers another service, Azure Container Instances, and there you have unlimited CPU and memory. With the virtual kubelet, you can make use of this. And then you end up with worker nodes and the virtual kubelet. The ideal situation is to have the master node, which is already managed, and the virtual worker node, which is also 100% managed, but that is not possible yet. But you can use this right now. So the end of the section, this is the whole script that we are applying, and of course we automate it. So we have learned a lot again. First, people like to use the dashboard, but you have to do something to make it work. The current AKS version is partly managed, and you have to do something yourself. Luckily, we have a rich ecosystem, and we can make use of that, and we automate everything. And of course, Helm, if you're not using Helm, I would not know what I have to do without Helm. And then we are finally there to run our applications. The cluster is ready now. But I want to tell you something about how we deploy our applications. Besides that, I have to tell you something about stateful applications, monitoring, and using the key vault for secrets in your applications. So let's go. I showed you this slide before. A Kubernetes cluster per environment per team. But as you can see, our team, first we had one development environment, but the teams were asking for more because we are working in feature branches in Git. So multiple team members are working on a feature, and actually they wanted to deploy this to Kubernetes. So they requested this, and we support this now. So we support to deploy multiple development environments to development. And we do this using namespaces. It's a simple concept in Kubernetes. And everybody is using namespaces because by default you use the default namespace. But you can create your own custom namespaces. It's a logical boundary of resources in Kubernetes. So how are we doing this? Well, we started deploying our application by creating deployment files, a YAML file for our service, and a YAML file for Ingress, for example. And here you can see that we just specify a namespace, and the namespace consists of the repo and the branch. So all we had to do now was create a template for this. So now these are variables, and we can replace these variables with the actual value. Works great, except for this part. This is the domain name where we can access our applications. And it has the environment name in it. At the bottom, you can see our pipeline, which we use in Azure DevOps. So we first have a build pipeline, which is creating artifacts, and then we have the release pipeline. We first release to development, staging, production. It's a best practice that if you have scripts like this, these are artifacts. So we want to have the scripts there, and they are built by the build pipeline. And that's the problem, because the build pipeline doesn't know in which environment we are going to execute this script. So we can only deploy the development script. Of course, I could execute this script 3 times, then I end up with 3 scripts, 1 for development, 1 for staging, 1 for production, but I don't really like that. So we had a look. First, this is how it looks in Azure DevOps. Use the replace task, and it works great. To solve this, we took a look at Helm again, because till now we were using Helm to provision off-the-shelf applications to our cluster, but you can also use Helm to deploy your own applications. So we tried it out. With Helm create, in this case, pod info, it was the name of the project, you get a directory structure like this, with charts, templates, and some files. The templates directory consists of, well, actually, exactly the templates that I created manually. So a deployment, the ingress, and a service. Although they look a bit different, this is the syntax that Helm is using. It's really a template. The variables are being filled by this values file. So this values file contains all variables, and actually these are more or less the fixed values. So if you want to use ingress, yes or no, the port and type of service that you're using, it will not change that often. The most beautiful part, and the reason why we are using this now, is that we can also provide variables during the execution of the command itself. So in this case, we can provision the version, the tag of the Docker image, and the domain name. So now we can execute in our release pipeline this command. It looks like this. This is the release, and after install and initialization of Helm, we apply an Helm upgrade, just like in the scripts. And as you can see, the image tag is used by filling in the build ID. And the domain name is based on a variable in this environment. So this is how we deploy our applications. And then teams are using volumes sometimes, storage. And that's a story on its own. So you have multiple options here. You can use, well, the old way in Kubernetes to configure a volume. If you need storage in your Docker container, you need to mount a volume. And if you need it in your Kubernetes cluster, you mount a volume to your pod. So this is how you do it. This is the pod, and we access a storage account here. And you can choose between file or disk access. If you use a volume, you can see that there is cluster configuration in the pod deployment. Some people don't like that, because now my pod deployment contains cloud-specific configuration, and they don't want that. So that's the reason why Kubernetes came with persistent volumes, dynamic or static. They look the same, and actually you only have more levels now. Now the configuration is not on the pod anymore, because the pod contains a persistent volume claim, but now the configuration of Azure is in the storage class. So, okay, but it has consequences in using this. If you provision an AKS cluster, Microsoft is creating a new resource group for you, which is generated, and it contains all the virtual machines. If you use persistent volumes, then your storage account must be in the generated resource group. With the whole provisioning, where we are in control of our AKS cluster, I try to avoid touching that generated resource group. And now I have to put my data in it. I really don't like that, but it's a consequence. It has more consequences. You can configure access mode, and you can choose between Azure File or Azure Disk. Azure Disk is really a disk. It's a VHD file, so you can't access your data direct. It's in the VHD. It is slow because you have to mount the volume to one of the worker nodes. And you can only support one pod only because it only supports access mode read-write once. On the other hand, Azure File, which supports all access modes. Unfortunately, it is pretty slow because it's just an SMB, it's just a share. It's not offering the premium support, and Azure Disk is offering the premium support, so it can be fast. So you end up, actually you want to use Azure File, but it is not fast. So what we have learned is actually very simple. Try to avoid using volumes. It is just too slow. The only reason, in our opinion, that you can use volumes is, for example, when your Docker container starts and it needs a configuration file. Or maybe it needs a secret. So only for startup. At least you are warned that Azure File is very slow and it's actually the only volume that you can use. A word about monitoring. So we started with application insights for our custom developed applications. And that worked pretty nice. You need to set a reference to the application insights library, and then you can log. But we were also using Airflow, for example. Airflow is an off-the-shelf application. I can't set a reference to a library in Airflow. The common way, if you use Docker, is that loggers should use the standard out. So what is being written to the console should be logged. Luckily, Microsoft came with the log analytics support, and that supports the standard error and standard out. So now our logs are just logged the way it should to log analytics. It works great. Unfortunately, we don't have an application map. If you have seen that, it's a nice overview of your whole architecture and gives you great insights. So now, with log analytics, we are more cloud independent. Because if you have a reference to application insights in your Docker container, well, then I can't deploy my Docker container in another cloud, of course. So we like this. And actually, it looks like this if you configure it. So you see the health of your worker nodes, of your pods. You can see how much memory they use. So it's easy to configure, and you get quick insights in the health. But you are missing the details that, for example, the de facto standard Prometheus is logging. So the rest of the world is using Prometheus. Luckily, again, in preview, there is Azure Monitor for Prometheus. So now we can have the best of both worlds. We can have log analytics with its ease, and we can use Prometheus adapter for the details. We don't have to install Prometheus itself. Now Azure Monitor is an endpoint for your Prometheus logging. So you don't have to do anything for it except enabling it. So that is very nice. The last part about secrets. If you use secrets in a pod, which you will, well, most often use, for example, a connection string, you do it like this. On top, it's the configuration of your environment variables, and it's using a secret. The secret is created by YAML as well, of course, and the name secret is a bit overrated because secrets in Kubernetes are base 64 encoded. So it's called a secret, but it is not a secret. But we could use the key vault. We are already using it during our provisioning, so why not use it for our applications as well? If we use the key vault, then we need access to it from our pods. We could use a service principal, but then we have a username and password. The password should be stored somewhere in Kubernetes, maybe as a secret, but we are using the key vault to manage the secret. So now we have the chicken and egg problem. That's the reason why there are managed identities. A managed identity is a service principal, but only a resource in Azure, in this case K8S, can have can use this service principal, this managed identity, to access other resources without a password. So this is what we need. Unfortunately, you can't use a managed identity with AKS yet. Hopefully Microsoft is working on this. But there is a solution. Again, Microsoft created some open source projects. You can find them on GitHub here. And both can be installed using Helm. If you do this, well, then you have access to your secrets. I have a smiley because now I've reached my goal. I can read secrets using a managed identity for my applications, but there are also disadvantages. For example, it is the key vault flex volume. So again, a volume is mounted to your pod. So that means that you don't get an environment variable in your pod. It means that you have to read a file because a volume is mounted, so each secret will be one file. If you read the file, then you read the secret. For our custom applications, we can do that, we can change it. But in the sample for Airflow again, we can't use this. So, but for now, we are happy enough with this. So this is the last section of the presentation. And we have learned again a lot. We have learned that monitoring with log analytics is very nice, especially with the preview functionality. And we try to avoid using preview functionality in production, but we are using this one. Also, a nice lesson learned is that we can use Helm not only for off-the-shelf applications, but also for our own applications. And it looked a bit hard because it's again something new that we have to learn, but we are fine with it. The advantages are bigger than the disadvantages. And again, we automate everything, so this as well. So many people are choosing Docker and Kubernetes to be cloud independent, and you are cloud independent. But you're not only using your Docker image, you are using databases, other ways of storage. You are using network components, and those are really cloud dependent. So you have to think about it, was that the real reason why you moved to Docker and Kubernetes to be cloud independent? Are you really are? I don't think so. It's really hard to support multiple clouds. We are applying DevOps as a team. So everybody can do infrastructure, everybody can develop, but it is hard. It takes a lot of time and knowledge of everybody in the team. We automate everything, and it takes really a lot of time, much more time than you could ever think. The scripts that I offer you, they have costed months of work. But once you have it, once you have this DevOps way of working, you are applying infrastructure as code, it's so nice. And the time to market is much shorter. We are so fast as a team now to deploy our applications and deploy our infrastructure, everything that's related to it. So thank you for joining my session. The scripts can be found on this GitHub account. If you need an introduction into Kubernetes, I've written an article together with a colleague. You can download a free magazine on this URL. Well, thank you. And if you like a sticker, grab one. And come to me if you have tweeted some pictures and want a t-shirt. Have a nice day.
Thank you, Pascal. Thank you. We are just, you're pretty sharp, pretty accurate. It's 12:20, so for that we can make some noise again. This is fantastic, fantastic timing. And so we can allow you to answer one of the questions. So we have one that is pretty much viral, 11 likes. So this is the one. What do you base your firewall configuration on, IPS or something else?
I base my firewall configuration. Who asked this? I don't know exactly what you mean with IPs, or because the firewall. Do you mean on the back end? Who is? If I understand you well,
So
then
when you set the firewall, you need to set a firewall.
Yep.
Of the backends and everything.
Mhm.
What was the configuration based on? You just were filtering to accept traffic from a specific IPs, public IPs, or you were doing a different kind of configuration?
Yeah, our applications are using OAuth, and so we already have authentication. So we don't need any restrictions in IP addresses. And the branch offices, they change IP addresses all the time, so we couldn't whitelist. We wished, we tried, but it was undoable to apply whitelisting. So actually the whole world can access our cluster, and by applying OAuth, that's why I told you this, well, we have authentication, authorization, well, together with the level 7 firewall for the standard OWASP rules. Yeah, it was good enough for the security department. So we don't do any whitelisting on IP addresses or something like that.
I think that's it. Well, thank you. We have a little gift for you. Make some noise. That was Pascal. Thank you. You
Thank
guys.